Hello viewers, welcome to Physics with Sanmitra. I am Sanmitra Bhomik and today I am going to teach you about pseudo force. We are learning the chapter Newton's laws of motion and today our topic is pseudo force. So pseudo force means what? Pseudo means false. So this kind of force actually doesn't exist or actually isn't applied physically, but this is considered due to some purpose. So what is pseudo force and why is it applied? So why is it considered? We will be looking within a few minutes. Okay. So let's begin the topic. So why pseudo force? Why we need to apply pseudo force? First of all, pseudo force is any force which is not physically applied, but we have to consider it because of certain reason. Now let's look at the reason why. In non-inertial frame of reference, Newton's laws of motion cannot be used. So what is non-inertial frame of reference? Suppose, let's say this is a bus. You are standing inside the bus and let's say this is me. I am standing outside the bus. This bus is moving with an acceleration a. This bus is moving with an acceleration a. Now, let me say this is frame 1 and this is frame 2. That means the frame in which you are standing inside the bus, that is frame 1, and the frame at which I am standing, that is frame 2. Now, this total frame is moving with an acceleration a. So I can say this frame 1 is not an inertial frame of reference with respect to me, who is standing at frame 2. So suppose I want to analyze the force that is acting inside bus, acting on this person, say. So I want to analyze the force that is acting on this person. Now, what I have to do is that I have to, first of all, I cannot analyze it with respect of Newton's law, with the help of Newton's laws of motion, because Newton's laws of motion cannot be applied like this. It should be in inertial frame of reference. So we have to account for this non-inertial frame to make it inertial frame. To analyze this, we have to make it inertial frame. To change our frame of reference so that we can make our current frame inertial. So I have to do something by which I can make this frame 1 inertial. So what can I do? That we will see. To account for the equilibrium condition of the non-inertial frame, we have to include a pseudo force. Okay, I think even now this is not that much clear because I am just reading out the words. So let's go and let's learn with an example. Okay, this is the example. Just see here. This is a bus. Inside the bus, person A is sitting, and outside the bus, person B is standing, and there is a block of mass M which is lying on the bus, and there is no friction. I repeat, there is no friction between the block and the floor of the bus. So this block mass M is placed on a frictionless floor, and person A is sitting on the chair, and person A is, you can assume, it is attached to the chair, attached to the bus. Now, the bus is moving in the right hand side with an acceleration of a. When the bus is moving with an acceleration of a, what will happen? What observer B is watching? Observer B is watching that a force is applied on the bus. That is why it is moving with an acceleration a. That is F is equal to ma. Now let's look at what is happening next. See, this block of mass m, it is not at contact with the surface because it is kept on a frictionless surface. So as the bus moves forward, there is no force of contact between there is no horizontal force of contact between the surface and the block m. There is normal reaction, I agree, but this horizontal motion cannot be transferred to this mass m by any means because there is nothing here. So this block of mass m will be absolutely at the same position with respect to the ground or observer B. See, I have drawn the line here to show that this block m is at the same position with respect to observer B, because this surface is super smooth, extremely smooth. There should be some friction to carry this block m along with the bus, but there is no friction. This is zero friction. Now what is happening? This bus is moving forward, so person A or observer A is also moving towards the block. Now let's look at the second one here. In the second picture, this block is stationary with respect to the block B. Now this person is moving towards this block of mass m. He is moving towards this block of mass m. And see here. Now let's talk from the point of view of observer A and observer B. What is happening? Since the bus is moving in the right direction with an acceleration A, so observer B, what does observer B sees? Observer B sees that no force is being applied on this one. There is no force. That is why it is at rest. And there is force that is being applied on observer A's frame, that is the bus. That is why the bus is moving forward with an acceleration A, that is F is equal to ma. Clear this much? Since force is applied on the bus or on observer A also, because observer is inside that frame, so that frame is moving forward with an acceleration A, rightward. But what does observer A see? Observer A, according to observer A, just see here, according to observer A, this bus is at rest. This bus is at rest. Observer is not feeling that the bus is moving forward. Say it's a super luxury bus with all kinds of shock absorber, etc. So there is no jerk in the bus. Super smooth journey. Now observer A is not feeling that this bus is moving. But observer A is seeing that this block is coming towards observer A. Observer A is watching that this block is coming towards observer A with an acceleration of, this block is coming towards observer A with an acceleration of A. This block is moving towards observer A with an acceleration of A, that is the acceleration of the bus. So observer A feels that this block of mass m is applied with a force, that is F, from the in the backward direction of the direction of acceleration. That is why it is moving with an acceleration A. This is what A is watching from inside the bus. A doesn't know anything that the bus is moving or not. A is just watching that this block of mass m is moving towards A. Now let's write the equation. F is equal to ma. Now for observer A, this frame is an inertial frame of reference. Now F is equal to ma, we can write, and this force F is actually not applied. This force F is actually not applied, and this force is called the pseudo force. The pseudo force, that is to, now if we want to apply Newton's laws of motion inside the frame of the bus, then we have to consider a pseudo force. Then only we can account for the motion of the block M with respect to observer A. But to remind you again, to observer B, this block M is at rest. It was at the same position as it was earlier. But to observer A, it is moving backwards. Because according to observer A, the bus is at rest. So exactly this is what I want to show, that how this F is equal to MA, how this F is equal to MA is coming, because what A is watching, that is this block F is coming towards him with an acceleration A, because the bus is moving in the rightward direction that we can see from outside, but A is watching that this block M is moving towards him with an acceleration A. So for that acceleration there should be a force, and that force is pseudo force that only A can observe, not B. I hope now this is very clear. If you cannot understand, then watch this part once again. You will definitely understand. And still, if you have some doubts, please feel free to leave it in the comment section. Now, let us consider a case of a lift. A person is in the lift, and the lift is moving up. A person is in the lift and the lift is moving up with an acceleration A. Now let's analyze it. See, the person is inside the lift. Now suppose you close your eyes inside a lift. Can you understand that the lift is going up or not? First of all, the lift has no windows. Most of the lifts do not have. Some of the lifts have, but a few of the lifts do not have. Suppose you are not looking at the window, then how can you understand that the lift is going up or not? Actually, you can by feeling it. We'll show how. But you cannot do it by seeing. So he will feel that he is standing on plain ground. Now suddenly he will feel that his weight will start increasing or decreasing. He will start feel heavier, or he will start feeling lighter. Now let's see. This is the man whose mass is M. So mg will act downwards. That is the weight. Now see, the lift is moving upward. Now exactly in the previous slide I have shown, if the bus is moving on the right hand direction, then pseudo force will be acting in the left hand direction for the person inside the bus. For the person inside the bus, for the observer within that inner non-inertial frame of reference. To make it inertial frame of reference, we'll add that pseudo force. So exactly the same thing we will do for the case of lift. This person is inside the lift. So he will not know that the lift is going up or not. He will experience that this lift he's experienced another force, that is M into A in the downward direction. And there will be a normal reaction from the ground because it is touching the surface of the ground, so there will be a normal reaction. So I have drawn the same free body diagram here in a neat fashion. So you can watch this part. See, now I think it is clear why mass into acceleration, this MA, this pseudo force, why it is acting downward, because the lift is moving upward within that acceleration, and the person inside do not know the lift is moving upward or downward. So to the observer in the frame of the lift, a downward pseudo force will act, so that we can consider this lift as an inertial frame of reference. Then only we can apply the Newton's laws of motion. Okay. Now this is N, this is mg, and this is ma. So after you see, N is equal to mg plus ma. N is upward and mg plus ma is downward. So N is equal to mg plus ma. So N is equal to m of g plus a. That is the weight you will be feeling. See, there is a big misconception among students that they feel that mg is equal to the weight they feel. That is not true. Mg is equal to weight. W is equal to mg is the weight. But they feel the normal reaction from the ground. So they will start feeling heavier in this case, because see, G plus A is heavy. They will feel heavier, because normally it was m into g, that was n, but now you see, now it is m into g plus a, so they will be heavier. So G effectively, or G dash, will be G plus a. Okay. Now the next case is lift moving down. The lift is moving down with an acceleration of a. Here the lift is moving down with an acceleration of a, and this person is in the lift and his mass is m. Now let's draw the free body diagram. I have already drawn in the, there will be mg downwards, there will be an n from the surface. Here there is a surface, so there will be n contact force, and the lift is accelerating downward, but to this person this lift is stationary, because he is inside the frame of that reference. So he will feel a pseudo force that is acting upward. See here, he will feel a pseudo force that is acting upward. So the thumb rule is, the direction, pseudo force will act in a direction opposite to that of the direction of the acceleration of the frame with respect to the ground, or with respect to another frame. Okay. So this MA will be acting upwards. So NA is upward, MA is upward, and N is upward, MA is upward, and MG is downward. So N is equal to MG minus MA. MG is downward, MA is upward, so MG minus MA. Or N is equal to G minus A. So this is clear, I guess. So you will be feeling lighter. See, because G minus A, that is reducing G. See, if A was 0, if acceleration was 0, then N would have been simply mg. Normal reaction will be same as the weight. But when the lift is accelerating downwards, so this component, this MA, will reduce this N. As the MA increases, this N will decrease. So exactly that one I want to say, that is M is equal to G minus A. That will reduce your effective weight and the field, the weight which you will be feeling. And so I can say G dash is equal to G minus of A. That is effective acceleration. So it is decreasing. Now what happens if G is equal to A, or when A is equal to G? What happens when A is equal to G? That time normal reaction becomes 0. So you will start feeling weightless inside the lift. You will suddenly feel what is happening? Why am I losing contact with the ground? So you will lose contact with the ground, and that situation is called free fall. FREEFALL. And that situation is called free fall. So you are falling freely. Okay, now one more question. This also comes in the MCQ. So A is equal to G, it will be free fall, and you will start losing contact with the ground. That happens when the string of the lift or the cable of the elevator is cut off. When the cable is cut off, the elevator starts falling and you will start losing contact with the ground. It will make a free fall, that is A is equal to G. And you start feel weightless. Okay? Now what will happen if I don't want you all to experience this kind of situation inside a lift, definitely not, but just for knowledge purpose. If A is greater than G, then what will happen? If A is greater than G, first of all, there will be no normal reaction here. This will be your MA and this will be your MG. This MA is greater than MG. Now what will happen? That will be a very dangerous case. You are in the elevator. Okay, let me take the black screen. This is the elevator. What will happen is that since this is MA, this is MG, I am doing it from the reference of the observer inside the lift. So MA and MG, since MA is greater than MG, you know what will happen? He will go upward and he will stick with the ceiling. He will stick with the ceiling of the lift. See, now I am looking from the point of view of an observer outside the lift. What will happen? This is also very easy. I need to know the two values. See, you are falling with an acceleration g, and the lift is falling with an acceleration a. So this part, this ceiling, is going faster than you are going down. So definitely this ceiling will touch your head. So what will happen? You will stick to the, or you will collide with the ceiling of the elevator. So what will happen if A is equal to G? Then both will be falling at the same rate. So that is the thing. So now you can understand what will happen if we analyze from inside the frame of the reference, that is inside, from the perspective of the person inside the lift, and from the perspective of a person who is outside the lift. Okay. So I think you will not be facing any problem in case of lift. Why it is n of m g minus a, why it is n of m g plus a? You have to know how to draw the free body diagram. If you have problem in drawing free body diagram, then you can please refer to our lecture of free body diagram that is present in this playlist only. Okay. Okay, now let's solve a question. Find the acceleration of the cart so that block A remains in equilibrium with respect to the cart. This is block M2. This is block A. This is block B. B is M1 and A is M2, the mass. There is a cart and there is a pulley, this arrangement. Now, this cart will be given an acceleration in such a manner that this block A, it will remain stationary or in equilibrium with respect to this block. Now understand one thing. If I keep it just like that without giving any acceleration, what will happen? Definitely this M1 will go down and M2 will go this side. We have already covered this type of questions in free body diagram section, or we have covered these problems. But to keep this constant, what we will do, we will provide an acceleration. Now in which direction? Right side or left side? We will provide it in right side, because if we provide that in right side, this one will have the tendency to stay here at the same place and this will move. So by that, this tendency of this block M2 to stay at this position, we will try to keep it at this position only. This is from the point of view of the observer outside the system. Now let's analyze it from the point of view of the observer who is in the frame, in this frame, accelerated frame. We will give the acceleration this side. So this will face and this will experience an pseudo force, that is M2 into A. So this M2 into A will help this stay in this position. Now let's draw the free body diagram. This is very simple free body diagram. For, let's say, for block A. Block A, there is a tension in the string that will be acting like this. See here, the string, the tension will be acting away from the string. This is T, and here it will be T. So here it will be T, here it will be M2A, and here it will be T, here it will be M1G downwards. So this is T, this is M2A, and definitely there will be M2G, that is the weight here. There will be M2G weight here, and there will be normal reaction from the surface. Let's say this is N2. But these are not necessary, because this block is already at equilibrium with respect to the perpendicular to the surface. If the block is perpendicular to the surface, then it is already at equilibrium. That is the constraint relation. So it cannot move in the y direction. So summation of Fy, that is already 0. So this we'll consider only the x component of the forces in the x direction. Now let's see on the free body diagram of the block B. M1G is acting in the downward direction, T is acting in the upward direction. Now see one thing, I have not shown two forces here. See here, this cart is moving with an acceleration a. So definitely a pseudo force m1 into a will act here, m1 into a, and that will be balanced by, say, n1, normal reaction from here. Okay, but this is not required, because that is, in our question, that is not required. n1 is equal to m1, that is an equation, but we don't need here. We are just showing this much. So this is, let me, for the sake of completeness of this question, this is n1a and this is m1. This is n1 and this is m1a. Okay. Now we know from here, let's clear this. Okay, just showing only those forces which we need. Now this is T, this is m2a, these two should be equal for equilibrium. T minus m2a, that should be 0. T is equal to m2a. T1 is equal to m1g, and by solving them, by taking the ratio, we will get A is equal to m1g by m2. This much should be the value of the acceleration, so that this block be at rest. This one be at rest. Okay, I think this much is clear. Now the next question. Find the minimum value of F so that the block of mass m does not slip down. See, we have a cart that is having a mass m. We have another mass or block of mass m which is kept just like that without any support. But there is friction between the two blocks, the bigger block and the smaller block. Now we are applying a force F here. There is no friction in the ground. It is having wheels. Nothing is mentioned, so no friction. We are applying a force F in F here, and this whole setup will start accelerating in the right hand direction. Now you can feel it when you are pushing it. When you are pushing it with a large force, this will tend to stick here. You can feel that. Physics is all about feel. So if you can feel it, then you can solve it. So when you are pushing it with a large force, definitely this will tend to stick here. You can feel it, but now you have to express it mathematically. How will you do so? Very simple. Let's draw the free body diagram. See, drawing the free body diagram, this is F. This is the F which you are applying, and see, there will be mg. Mg will be acting here actually. Mg will act from the center of the mass. Anyways, these are the two reactions from the two wheels, and this block M, this block M is in contact with this mass small m. These two surfaces are in contact, so there will be a normal reaction. Okay, this friction I am telling. Wait, this friction I will be telling. Let's analyze this one at first. This is the block of mass m, and a force mg is acting. That is the weight. This normal reaction will be acting from this surface, and see, this surface, this block has the tendency to go down. This block has the tendency to go downwards. This block has the tendency to go downwards. So if this block has a tendency to go downwards, then the friction will be acting upwards. When the friction will act upwards, friction opposes relative motion. These all things I have covered in the friction lecture. Okay. Now, this is F and this is N. This is N and this is F. This F is acting upwards. Then in this block, F will act downwards, because F is actually the horizontal component of reaction force, and reaction forces are equal and occur in equal and opposite pair. So this is F and this is F, and this is N and this is N. If this N is acting on the right hand side, this N will act on the left hand side. This N is acting on the right hand side, this will act on the left hand side. This is acting on the upward side. So exactly same and equal and opposite friction force will act on the downward side. Simple. And one more force, this M into A, this is acting on this one. Because we are considering this frame, just look at this properly. only this block, this small m, we are considering it as this is actually the non-inertial frame, and we are standing on this block. We are standing on this block, or we are observing from this block to analyze the forces on this block. Okay. So this is moving with an acceleration a. So definitely, as I said, they are not slipping. So this will also move with an acceleration a. So since this is moving with an acceleration a, this will encounter a pseudo force. This will experience a pseudo force, that is m into a, in the opposite direction to that of the acceleration. Now our free body diagram is complete. Now let's write the equation. This is the free body diagram, the first one. See, in the x direction, f minus n, and it is moving with an acceleration of a. So f minus n is equal to capital M into a. Now mg is equal to r1 plus r2 minus f, or mg plus f is r1 plus r2. This equation I can say this is not needed. This is not needed. I will tell you why. This f minus n is equal to m into a, just for the sake of completeness we wrote. Now the second one. This is let's draw the free body diagram. Same free body diagram. This is mg, this is ma, this is n. See, mg is equal to f. This mg is downward, f is upward. So this is at equilibrium. So mg is equal to f. Because this block is not moving downwards, is not slipping downwards. And this block is constrained to move along the larger block. So this n will be balanced by this ma. Why this ma is happening? Now understand it conceptually. When we are applying a force of capital F to the larger block and small block system, then the whole arrangement will go with an acceleration a, and due to that acceleration we are getting a force of small m into a, pseudo force, that is acting with respect to an observer who is in the frame of reference of the smaller block. Now this small m into a, if that is large enough, that will increase this n. Now for the limiting case, friction is equal to mu s into n. Okay, friction is equal to mu s into n. If n increases, then friction will also increase. If friction increases, then the block can be held by the friction forces. Very simple. It can't be simpler than that. As we are applying the force, the whole arrangement is moving with an acceleration a, and due to that, a pseudo force is acting on the small block of small mass m to an observer who is observing from the frame of reference of the smaller block, and due to that, normal reaction increases, as we can see in the free body diagram, n is equal to ma, and that increases the friction. Okay. Now see here, f minus n is equal to ma from the last diagram, and n is equal to ma from here. So f is equal to m plus m into a. This we can write directly also. F is equal to m plus m into a, considering it as a system. So a is equal to f by m plus m. A is equal to f by m plus m. Now see, f is equal to mu s into n. So friction is equal to mu s into m into a. See, n is equal to m into a, so f is mu s into m into a. F is equal to mg from here. This friction force is balancing this force mg, weight. So mg is equal to mu s into ma. A is equal to g by mu s. A is equal to g by mu s. So what is the value of f? Now we can find out the value of f. A is f by capital M plus small m is equal to g by mu s. So f will be equal to m plus small m g by mu s. So that is the answer. This was one of the, I say, brainstorming questions, or you have to apply your brain. You have to understand how am I applying the force F and how it is affecting the normal reaction. That you have to understand. Okay, the next question. See, there is a cart that is moving with an acceleration, say a, as shown. This cart is moving with acceleration a on the right hand side, and it is and the G is acting acceleration due to gravity kept vertical. Find the angle of the pendulum when it is in equilibrium with respect to the cart. See, this pendulum is in equilibrium with respect to the cart. That means to a person who is standing inside. See here the pointer is the person who is standing here. He or she will see that this cart is making an angle. It is at equilibrium. This pendulum is at rest with respect to this observer. But to an outside observer, this pendulum is also moving with an acceleration a. So this, with respect to the cart equilibrium, this phrase is very important. Okay, now I think you can get the idea how to do this. Since this pendulum wants to retain its position, it was here, so it wants to stay here. Since the cart is moving forward, this pendulum is forced to move forward, but it wants to retain. So this will be something like this. Initially it was something like this. Say I'm showing with different color. It was something like this. After moving, this pendulum position won't change, but this cart is moving forward. But to an inside observer, that person will see that the pendulum is experiencing a force of m into a in the opposite direction of the motion. Okay, let's draw the free body diagram. Free body diagram I can show you here. See, there is a pseudo force that is acting. I'm observing it from the point of view of somebody standing inside the cart. So this is m into a is acting in the opposite direction. Mg is acting in the downward direction, and tension is acting along the string, that is making an angle theta with the vertical. So we are resolving this t sin theta here and t cos theta here. So t cos theta component will balance this weight mg, and t sin theta component will balance this ma. So a by g, that will be equal to tan theta, and theta is tan inverse of a by g. See, the mathematics is very simple. You can do it by your own. The concept is important. Why it is happening so? Okay, the next question, or the last question. There is a wedge that is on wheels, and it is making an angle alpha. The wedge is having an angle alpha. Now a block is kept here on the smooth surface. There is not mentioned smooth, so I am mentioning here smooth. What should be the acceleration of the wedge so that the block remains stationary with respect to the wedge? This is a similar question only. This is also very easy. Just we have to know how to draw the free body diagram and how to resolve it. Again, the concept I am telling you, I will not go into full details because you already know. See, this was the position of the block. I am observing it with respect to an observer outside. Now this wedge is going this side. This block wants to stay here only. Now what will happen? This wedge is going this side. This block wants to stay here only. Then it will go up. It will have a tendency to go upward. It will have a tendency to go upward because this wedge wants to stay here. This block wants to. Wedge is going forward. This block wants to stay here because of inertia. Then it will go upward. Simple. Now, this due to the gravity, what is happening? Gravity is acting downwards, so it will have a tendency to pull it downwards. This wedge wants to stay here. This block is moving forward. So what will happen? This mass will move. Will have a tendency to move upward. So these two can balance for a certain value of a. So that these two can balance for a certain value of a. So that this mass remains stationary with respect to the wedge. This I am observing from the point of view of an observer outside the frame, outside this frame. Now we will analyze the same thing with respect to an observer who is standing, say, inside the wedge. Suppose. Now what will happen? This person will see that this block of this wedge is moving. This person won't be able to understand that this wedge is moving like this. This person won't be able to understand. This person will see that this mass m, this is experiencing a pseudo force m into a, and it is experiencing gravity m into g, and it is experiencing normal force n. So without wasting any more time, let's go into the free body diagram. In the FBD I have shown you that this MA is acting in this direction because A was outside, right hand side, so MA will act left hand side. Weight is acting downward, and in normal reaction will act perpendicular to the surface. Now this is alpha. Now if we resolve this n into components, this will be n cos alpha, and this will be n sin alpha. See, now this is at equilibrium with respect to the block. So just if you can see here, this n cos alpha is balanced by the weight and n sin alpha is balanced by MA. So I have written the same thing here. N cos alpha is equal to mg and n sin alpha is MA. So A by G is tan alpha and A is equal to G tan alpha. So the same thing, the mathematics is very easy. The free body diagram, if you have watched my lectures or you know the procedure very well, if you know the procedure well, if you have no doubts regarding free body diagram or regarding friction and all, then you can easily solve these problems. Just you have to know, you have to understand the significance of the frame of reference. And if the non-inertial frame is moving with an acceleration a with respect to an observer on the outside, then from inside that frame, the observer, there is a pseudo force that is acting exactly opposite to that of the direction of the acceleration. Okay, so that's all for today, and I will be starting a problem series. For mechanics soon, after I have completed the basic concepts, and there I will be giving you more problems regarding pseudo force, and I will be combining them with various other concepts in mechanics, and that will be a very interesting problem series. And so if you liked my content, then please subscribe my channel Physics with Sanmitra, and please share this video with those who need it, those who are preparing for JEE or those who are preparing for NEET or any other student who wants to study physics well. Please share this video with them so that it may reach to those who need it. So thank you for your patient hearing.